Our first set of questions we're going to solve will be under chemical bonding, right electronic configuration, quantum number, isotopy. Yes, isotopy. So these are the words periodic table. These are what the first set of questions we are going to look at, right? I'm going to be like 10 to 15 questions under this one. Yeah, I really want to explain everything so that now, as I'm explaining each of the question, I will also be explaining what the topic. So you want to stick to the end of this video. So let's get into it here. So let's look at what question 1, question 2, question 3, and what question 4. Here we have this table, right? So let's look at what the question 1 here. The tetrahedral arrangement of the four covalent bonds of a carbon atom enable the atoms to assume an angle, right? Now, this is under what hybridization of carbon. Just and carbon have 3 types of hybridization here. Carbon have 3 types of hybridization. Now here we have what the sp3 hybridization, the sp2 hybridization, and the sp what hybridization. Now the sp3 hybridization, we have what single bond. All single bond of carbon are what sp3. Just and the sp2 are what is a double bond, right? While sp is what is a triple bond, right? Now here is what sigma bond. Now this is under what organic chemistry. Here is what sigma bond, 1 sigma bond. Here we have 1 sigma bond and 1 pi bond. So whenever you see sp3 hybridization is 1 sigma bond. Now whenever you see sp2, they are double bond. We have 1 sigma bond and 1 pi bond, right? And sp3 is what is 2 pi bond and 1 sigma bond. Now each of them have their bond angle and their structure. The structure of sp3 hybridized carbon is called tetrahedral. Right there, it's called tetrahedral. And the bond angle is what is 109 degree. 109 degree. So the bond angle is what 109.5 degree. Do you understand? So now whenever you see sp3, understand that the shape is tetrahedral and the bond angle is what 109.5 degree. Now for sp2, the shape is called triangular planar. Triangular planar. Right there, triangular what planar. And the bond angle here, so help for this stuff here, and the bond angle here now the shape of this one is called, the shape of the sp2 is called trigonal planar. Right there, trigonal what planar. And the bond angle is what is 120. Is okay. The bond angle is 120. Now for the sp3, for the sp is called what is linear. Linear shape. It's called is linear. Right there, and the bond angle is 180 degree. Just that. So these are the things you need to note when it comes to what hybridization of carbon. Do you understand? Yeah, they're asking of this sp3 here. Do you understand? They say that the tetrahedral arrangement of the 4 covalent bonds of carbon atoms enable the atoms to assume and the bond angle of what? The answer is what is 109. Why? Because they say what tetrahedral what arrangements, and sp3 is tetrahedral arrangement, right? And the bond angle is 109.5. So, but there's no 0.5 here, so you can just take this on. This is what is the answer. You see this one here. So in the exam, they may bring this sp2, they may bring what is sp. Do you understand? But understand here, please take it down inside your notes. So we are done with the first one here, right? So let's look at the second one. So if you look at what the second question here, please pay close attention. If you look at the second question, you see that what is the maximum numbers of electrons in the 2p subshell? Now here we have 2p subshell, right? Now remember we have 4 4 orbital. Here we have what? The x orbital, the p orbital, the d orbital, and the f what orbital, right? Each of them have that sub orbital, which sub share, right? So here, s orbital have what? One sub orbital, one what sub orbital. P orbital have what? 3 sub what orbital. Is okay. D have what? 5, 1, 2, 3, 4, 5 suborbital, right? And F have what? 7 what? Suborbital. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's okay. Now, what you need to understand here is that here the ask number of 2p. Now, this 2 is the what? Is the energy level. P is the what? Is the orbital. Do you understand? Because they are talking about P. Look at from here. P have how many suborbital? 3 suborbital. Now, in the arrangement of electron here, one suborbital can take the maximum of 2 electrons. So the maximum number of electrons in which S to accommodate is what? Is what? 6 is what? Is 2 what? Electrons. Is what? Is 2 what? Electrons. So the maximum number of electrons in which what? S orbital can accommodate is what? Is 2 electrons, because X only have 1 suborbital. And a suborbital can only accommodate what? 2 electrons, maximum of what? 2 electrons. P is having what? 3 suborbital, right? Because you have the 3 suborbital, remember, one can accommodate 2, right? The maximum numbers of electrons each P can accommodate is going to be 6, because it will be 2, 2, 2. So the maximum numbers of electrons in which what P can accommodate is 6. So here we have what? 6 what? Electrons. 6 what? Electrons. Now D have how many suborbital? 1, 2, 3, 4, 5. 5 suborbital, right? So what is the maximum numbers of electrons? It's going to be what? 10. 10 what? Electrons. Right there. Then F is what? 7. 1, 2, 3, 4, 5, 6, 7. 7. 7 can, then 7 can have what? The maximum numbers of what? 14 what? Electrons. 14 what? Electrons. It's okay. Now here they are talking about P subshare, right? Now the P subshare, they ask here, what is the maximum numbers of electrons in P subshare? They're talking about P, and P can accommodate electrons. So the answer is what? Is B. The answer is what? Is B. Do you understand? So now here they say these two do not have any effect. Even though they say 4p is the P you are looking at, not 4. Do you understand? No matter the number, the orbital is the most important. So this is what we have done with question 2 here. So as they say D could have been what? 10. If they say F could have been what? 14. If they say S could have been what? Be 2. But they say it's P, which is what? Is 6. Hope you understand. So we are done with what these two things here. So let's look at our question 3 and question 4. Very important. So if you look at what question 3, if you look at this table here, use the table to answer the following question. If you look at the table here we have group 5, group 6, group 7, and what? Group 8, right? You have elements R, which is what their atomic number is what? Is 7. Element S, the atomic number is what? Is 8. Element Y, the atomic number is 9. Element Z, the atomic number is what? Is 10. Element 10 is 15. Element Q is 16. Element what? V is what? Is 17. Element what? W is what? Is 18. Yeah. If you check, if you look at the periodic table very well, you know that look, these are the periodic table look like. Let me just give you a sample of the periodic table. Right? Let me give you of the periodic table. Yes, this is what is sample of the periodic table. Like is what a sketch of the world of the periodic table here. Now the periodic table have 4 main blocks. Here we have what? The S block, the P block, the D block, and the what? And the F what block. Just now. So now the S block have what? Group 1 and group 2. The P block have what? Group 3, group 4, group 5, group 6, group 7, and what? Group 8. Just done. The A block, we have 10 group, 10 of them. We have what? 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Is okay. So now the D block have what? 10. Why the F block have what? 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14. You see that? Now the S block, here we have the S block is what group 1 and group 2. The P block are what group 3, group 4 to what to group what 8, right? The L block is what transition metal. Why is it called inner transition what metal? Just now in your JAMB examination, their focus will be is what is the S block, the P block, and D block, less of the T of the D block. But we are going to see more is what is S block and the P block here. Now I have done a PDF. I have a PDF that explains the S block, the P block, and D block. I will leave the PDF and what description below so that you will go check out that what PDF. It's just a PDF. I'm giving you for what for free that explain the S block and the P block. It also explain the periodic properties, the ionization energy, the ionization energy, the electron affinity, electronegativity, electropositivity, and the rest. Just you must understand this here because JAMB normally asks this kind of question in the exam. Are they varies across group, down the group and across the period? JAMB normally asks this kind of question in the exam. I will not be going into those all those parts here, so I will leave the link at the description below so I can go check out what the PDF. Just now if you check very well, if you look at the element here, you have the following element here, right? Let me leave the element here. If you check this thing very well, if you look at the group here, you find that here we have V 5, 6, 7, 8. It's talking about from here, right? 5, 6, 7, 8. Do you understand? So from here to here, this is what they are talking about here in that question. It's okay. This is what they are talking about. Just 5, 6, 7, 8. This that. So 5, 6, 7, what 8. Do you understand? So this guy is the P block. So all the things you are seeing here are in the P what block. So if you look at it here, let's look at what the first question, the first question under here. Say the elements shows are likely to be S block, non-metals, transition what elements are what metal, right? It's not S block. It's not what S block. It's not what transition element, right? Because the transition element are this one here. These are what the transition what metal. The D block are transition metal. Do you understand? Now metal, no, it's not metal. Do you know the reason why it's not metal? S block are what are metal. Elements in the S block are what are metals, right? So they're part of the P block. But practically here, elements in block S and D are metals, right? Now, one thing you want to understand here is that from 5, 6, 7, 8, they are what non-metals. Just so what I want to do here is that the answer is what non-metal. They are not in S block, number 1. They are not transition elements, number 2. They are not metals. All these are from group 5 to group what 8. They are not what metals. So, but they are what non-metals. So the answer is what what metals. Very important. Number 4, how many electrons will be in the outermost shell of element represented as W? Right? Where is W here? Here we have W. Now, let me explain something to you here. Outermost electron is also now what the group number. Please take note of this. Outermost electrons is sent as what group what number. There. Outermost electron is also now the group number, and the group number is also now what valence electron. Valence what electron. So these are things to put down here. Outermost electron equals to what group number, also sent out valence electron. So element in group 1, their group number is 1. Element in group 1, their group number is 1. The outermost electron is 1, and their valence electron is 1. Element in group 2, their outermost electron is 2. Their valence electron is 2. Element in group 3, their valence electron is 3. Right? The outermost electron is 3. Now, element in group 8, their valence electron is 8. While the outermost electron is 8. Right? If you look at W here, W is in group 8. Do you understand? Is in group 8. So the answer is going to be 8. How many electrons would be in the outermost electron represented by what W? Now, here we have all these elements here. They are what R and T are in group what? Are in group 5. So this and this belong to group 5. Just Now F and U, they're under what, group 6. So they belong to what, group 6. While the atom's electron is what, is 6. Just yeah, Y and W and V, they are what, in group 7. Therefore, the atom's electron is what, is 7. The valence electron is what, is 7. Yeah, Z and W, they are in the same group here. Then what is under what, group what, 8. So the atom's electron is what, is 8. So the valence electron is what, no option here, but the answer is what, is 8. So atom's electron is equals to what, is 8. Do you understand? So yeah, but what you, like when I said, JAMB only bring the D block and the F block because they are beyond your scope of study. Do you understand? So they will not really dwell on asking you questions, the group of elements in the D block and the F block. Do you know? They only ask for the S block and the P block. So you want to study this one here, you want to study this one here, you know their elements. Remember, you know the tested elements: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, right? They move on, right? So that is why I say that I'm going to give you what, a free PDF that explains the periodic table, the group, the period, the block, and the rest. Just so I can go check out that PDF and read it for your own good. So we have solved what, the first 4 questions here. Let's move to the next set of questions. So now let's solve question 5, 6, 7, and what, and 8. Right? So please pay close attention here. Now, chemical bonding is one aspect of chemistry. JAMB like asking, like ionic bonding, covalent bonding, covalent bonding, metallic bonding, van der Waals force, and hydrogen bonding. So these are things you need to understand very well. I have done a complete video on this. I've done a complete PDF, right? That is wait for you to download them. Just so I've got the link at the word description below so that you can understand. Go and read them. Just so by the time you see any question, now the PDF contain explain each of the bonds and give what the possible questions you likely see in the exam. Just so let's look at this question here. The type of intermolecular force present in ammonia is, now this is the ammonia here. So let me write that. The type of intermolecular force present in ammonia is, so you have NH3 as the ammonia here, right? Now we talk about intermolecular force. Intermolecular force means what? The force, or yeah, the force that hold 2 molecules together. Just we're talking about molecular, is like ammonia here. Ammonia is like nitrogen, hydrogen, and hydrogen. Now, what force hold 2 molecules of hydrogen together is called hydrogen bonding. Just let me explain the hydrogen bonding to you. Right? Now, if you look at ammonia itself, this guy is high in electronegative power, right? Now, because nitrogen is higher in electronegative power, it will pull all the bonding electron away from hydrogen to form partially what, positive, partially what, negative. Yeah, partially positive, partially what, positive here, right? Now, this guy can also bond with another molecule of ammonia like this. If you look at another ammonia here, like let's say nitrogen here, hydrogen here, right? Here we become partially what, negative, right? The partially negative ends and partially positive end will bond together here. So what holds 2 different molecules together is called what, hydrogen bonding. Now if you look at the option, please pay attention. If you look at the option, yes, that ionic bonding is not the option. Why? Ionic bonding is formed between metal what's non-metal, right? That's where we talk about ionic bonding. The bond formed between metal what's non-metal. A good example is what NaCl is ionic bond here. Hydrogen bond, which I've explained, hydrogen bond is intermolecular force that holds 2 molecules together. Just they have metallic bond. It's not metallic bond. Metallic bond is going to form metal, so it's not metallic bond. Van der Waals force is not van der Waals force. Van der Waals force is the weakest force. Just so the bond that holds 2 molecules together is called hydrogen bonding. So it can be the same kind of question in the exam. please just tick what hydrogen bonding and go your way, right? Let's our question 6. Which of the following has weakest bonding power? We'll talk about weakest bonding power. What comes to your mind is called van der Waals force. Do you understand? Van der Waals force is the weakest bonding what power. I don't want to waste time on that. Van der Waals. Do you understand? Next, I want to look at is what is a metal X form 2 bromide with the formula XBRO2 and SBRO3. What type of bond exists between X and bromine in the bromine? Look at something here. Now, this guy here, you are seeing here, is a metal. Just that this guy is a metal, is a non-metal. Because only metal can, like, we have to call metal with single oxidation states and metal with what variable what oxidation states, right? Now, the transition metals like the zinc, the chromium, the nickel, the manganese, they have variable oxidation states. Just no, so those metals that have variable oxidation state, they can form variable what formula with what non-metal. So this guy is a non-metal. This X is a non-metal because this is a metal X from 2 bromine. Bromine is what is a non-metal. So we have metal plus non-metal. What our bond is formed is called what? Ionic bond. It's called what? Ionic bonds. So that now what's this kind of question here? Pick up what ionic bond straight. Ionic bond is the answer. Hope you understand. Question 8. The formula of the compound formed in a reaction between a trivalent metal and a tetravalent non-metal is, right? So let me explain stuff for you. It's very easy. This is called writing simple binary what ionic compounds. Writing simple binary what ionic compound. Now let me explain to you here. Now remember, when metal and non-metal, let us say X and Y, right? Combine together. This is what is metal. This is what non-metal, right? Now, they don't react with their ground states. Metal will lose electron in order to form the octet. Why non-metal will accept electron to what form the oxidation states, right? For example, here sodium. Look at sodium here. Sodium will have to lose 1 electron to form what? Na plus, right? Like calcium will have to lose 2 electrons to form what? Ca2 plus, right? Like aluminium here, aluminium will have to lose 2 electrons to form the octet. So you have what? Al3 what plus. Now, this guy is called monovalent metal. Monovalent what? Metal, right? Now, how is monovalent metal? Because it loses 1 electron to form this guy here. So it's called monovalent. This guy is called divalent. It's called what? Divalent. Just called divalent metal. Why is it called what? Trivalent metal. Now, if you have any metal that loses 4 electrons, it's called what? Tetravalent what metal. Do you understand? This is what you want to understand here. Now, the non-metal accept electron, right? The non-metal accept electron. Now, when they accept electron, they form what? A negative charge. Metal will lose electron to form a positive charge, which is called cation, right? While non-metal will what? Accept electron to form a negative charge, called what? Anion. Like for example, here, if you look at chlorine, Cl, right? For chlorine to have the octet here, it has to what? Gain 1 electron, right? So you have what? Cl what? Minus. Do you understand? Like for oxygen here, oxygen. If you look at oxygen here, for oxygen to have the octet, it have what? Gain 2 electrons. So you have what? O2 what? Minus here, right? Like nitrogen here, for nitrogen to have what? For nitrogen to have the octet electron, that what? Gain 3 electrons, which is what? N3 what? Minus here. Just this is called monovalent non-metal. Monovalent non-metal. Monovalent what? Non-metal, right? Now, why is it monovalent? Because just 1 here. This is called divalent non-metal, right? And here it's called trivalent non-metal. Do you understand? So you have to take note of all these things here because you are going to use them in the exam. Now, let us say, for example, please pay close attention here. Let us say, for example, here you are combining. Let us say, for example, you are combining what aluminium and oxygen, and oxygen here, right? Aluminium is what is trivalent plus, right? So you have what Al3 plus, right? Oxygen is what is monovalent here, right? Is what O2 what minus here, right? How they combine? It's very easy. The way they combine is very easy. Here we have what Al, which is what is 3, O, which is what is 2, right? Now you don't need to put the positive or negative sign here. You ignore them. Metal will come before what non-metal. So what will happen here? They will exchange their figures here. So this guy move here. This guy move here. So you have what Al2O what 3. It's okay. So this is the compound formed between aluminium and oxygen here. Now remember, aluminium is what is trivalent. We know why it's trivalent because it loses 3 electrons. The atom is electron, right? Oxygen is divalent. Why? Because it gains 2 electrons. But then here we have the metal. Here we have no metal. So what they will do here is that you bring some down here, and they exchange, right? So do what I'm saying here. The formula of the compound formed in a reaction between a trivalent metal. That means the metal is called trivalent, just like this guy here. So let me write this place out. So it's that the metal is what is trivalent and is what is M. So it's going to be what M raised to power 3 what plus. This is that M raised to power 3 plus. Why? Because it says tri means what 3. Valent means what the ion there, right? Trivalent metal. Because it says metal, that's why we put a plus here, right? And tetravalent non-metal, which is what X. So X is a non-metal and it's tetravalent. When you talk about tetra, what will come to your mind is what is 4. So we have 4 minus, right? Now the main reason why I put minus there because they say what tetravalent non-metal. That is it. So how do you form the compound here? It's very easy. You bring your M here and place 3. It's okay. Then X, you place your 4. Then bring this guy here, You are going to get N4 S3. It's okay. So this is the compound formed between a tetravalent metal and a trivalent metal and trivalent non-metal. This is it. So let's check the option. It's not this guy. Of course, it's this guy here. So C is what is the answer. Right? Because C is it, right? Now we still have a lot of questions to solve. We still have a lot of questions to answer in this video here. We are just starting. So now let's look at question 9, 10, 11, and 12, right? So look at if the electron configuration of an element is 1s2, 2s2, 2p5, how many unpaired electrons are there? Now let me explain to you, right? Let me explain to you. Now when I see something like this, you take the last one, right? You take the last here because we have 1x, 2s, and 2p. Now here, because we have got the inner electron, we have got the outermost electron, right? Now you're looking at the 2p, right? And you're looking at p. Remember p have how many suborbital? 3 suborbital, which is like this. It's okay. 3 suborbital, right? How many electrons are you seeing here? You have 5 electrons, right? So according to Ohm's rule, I'm going to use Ohm's rule to fill 5 electrons here. From there, you know the north of paired and unpaired electron. Just as here we have 5 electrons, we are filling 5 electrons into p orbital. Remember, according to Ohm's rule, Ohm's state that when filling electrons into the degenerate orbitals, electron must spin up before spinning down. That is the rule. When filling electrons into degenerate means suborbitals with the same energy level, right? Like this one here. Now, when filling electrons into degenerate orbitals, electron must spin up before spinning down. Now, since we have 5 electrons here, now let us spin up first. Here we have 1, 2, 3, right? So 1, 2, 3. Now out of 5, I've used 3, right? How many we left? 2, right? So the 2 now spin down. Now come back again and say what? 4 and 5. You have exhausted it here, right? If you look at this one here, I have 2 pairs and 1 unpaired. 2 pairs and what? 1 unpaired. They're talking about the unpaired electron, which is this guy here. The unpaired electron is what? Is 1. Why the paired electron is 2? But they're talking about what? The unpaired electron. So the option is what? Is 1. As easy as that. It's not difficult, right? Now, that is why you need to understand what's called quote number and write electron configuration. Very important to know all those things. Now, question number 10. How many electrons are in the L share of this one here? Now, what do you feel about what's L share? Remember, you have called the K share, the L share, K, L, M, and OP2. Let me wipe this place out. Let me wipe this place out here. Remember, in the structure of atom have a central core, right? Then you have the share here, right? The share are now what? The energy what level, and the energy level are also now what? The share, right? So you have what? My N1, my N2, my N3, my N what 4, right? So you have first energy level, second energy level, third energy level, fourth energy level. Do you understand? Each of them they are now shared, and they are denoted by a number, no, by an alphabet. They are denoted by what? By an alphabet. So now, when you have something like this, please pay close attention here. One, 2, 3, 4, 5, 6, and 7, right? Now, first energy level, second energy level, third, fourth, fifth, sixth, and what 7. Each of them they are denoted by what? By an alphabet, right? Here what? K, L, M, N, O, P, Q, right? So that my first energy level is that what is K shell. My second energy level is now L share. My third energy level is now our N share. My fourth energy level is now our N share. My fifth energy level is now our 0 O share. My sixth is what is P share. My seventh is what is Q share. Do you understand? Understand this here. Now they're asking you how many electrons are in the what L share. That is second energy what level. Just a second energy level. Now, for you to do this here, you need to write the electron configuration of what this element here. And remember, when you're writing electron configuration here, you use what? The atomic what number, right? Now for at your stage, when it comes to JAMB, let me give you what when it comes to write electron configuration here, let me give you what I'm going to use most, right? I'm going to use 1x, 2x, 2p, 3x, 3p, 3p, 4x, 3d. They won't exceed this one in your JAMB. Just and they will not exceed this one in your JAMB. 1x, 2x, 2p, 3x, 3p, 4x, and 3d. They won't exceed this one in your JAMB. Just remember that x we are accommodating how many electrons? 2 electrons. P we are accommodating how many electrons? 6 electrons. D we accommodate how many electrons? 10 electrons. Just now here we have 15, right? So now let's write the electron configuration of elements that have what 15 as well as atomic number, right? Do you understand? So now let's say what the first one here we have 1x. We take 2 electrons, you put 2 here. Remember how many electrons how many electrons we go to fill is 15, right? So we say what 1x2. Next one is what? Take 2x, 2x2, right? Take next one, 2p6, right? It's okay because S can accommodate 2 electrons. S can accommodate what? 2 electrons. P can accommodate 6 electrons, right? If you check very well, we have used 10. 2 plus 2 plus 6 is what is 10, right? That is out of the 15, I have used 10. I still have 5 left, right? We continue here, which is what? 3x2 and 3p3 is okay. So if you check it very well, this is the electron configuration for phosphorus, right? They're asking how many electrons are in the what L share. That is, the L share means what? The second energy level, right? Here we have first energy level, second energy level, and third energy what level. It's very easy. From the number, you know the energy level. First share, second share, and third what share, right? My first energy level, which is K share. My second energy level here is called K share, the L, and what and the M. Do you understand? Now we look at the K share. How many electrons do we have here? Here we have only 2 electrons. My L share we have a 2 plus 6, which is what 8. My M share here we have a 2 plus 2, which is what 5. Now they ask you how many electrons are in the L share, which is what second energy level. 2 plus 6 is what is 8. So look at 8 here, which is what is 8 here. This is the what answer. So you can see how I've used one question to explain so many things to you, right? So that is for this what question what 10. Now look at what question 11. Element X has the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Each atomic number and group number in the periodic table will respectively be. Now let me explain to you. So why this place at? Let me explain to you. Now, this is what is the electrical configuration, which is what 1x2, 2x2, 2p6, 3x2, 3p6, 4x2, right? Now, to get the atomic number, you sum it together here. 2 plus 2 plus 6 plus 2 plus 6 plus 2. It's okay, you're going to give you a 20. 2 plus 2, 4 plus 6, 10 plus 2, 12 plus 6, 18 plus 2, what, 20, right? So my atomic number is what is 20, right? Now, how do you get the group number? Group number. How do you get the group number, right? To get the group number is very easy. You look at what the highest energy level. The number of electrons in the highest energy level is what is the group number. Do you understand? You look at what the highest energy level. Now, when you are detecting the group number of any element at all, once you have written the element configuration, it's very easy. Look at what the highest energy level and sum up all the electrons in the what highest energy what level. If you look at this one here, you have 1, 2, 3, and 4. 4 is the highest energy level. 4 is what is the highest energy level, which is what 4x, right? How many electrons do we have in the 4s? We have 2. It's okay. Yeah, you don't just come and say 2. No, you put it in Roman figure. So what to be what 2. Just and so the atomic number, the respective is going to be 2, 20 and 2. That is it. So let's look at what the options. Here we have this one. The option is what B. B is what is the option. Just and B is what is the option. B is the what is the option. Hope you understand. So let's look at question 12. In the aluminium ion, this is called ion. In the aluminium ion, let me write this place out. If you look at what the aluminium ion here, you have what Al3 plus. You have what 27 and you have what 13, right? The mass number and the numbers of electrons are respectively. So they ask here, what is what the mass number? Mass what number? And what is the electron number? Electron what number? Again, what is your electron number? It's very easy here. Now let me explain to you. Now here we have X. It's okay. Let me say yes, X. Here we have A. Here we have Z, and here we have this A here, right? This capital letter A is what is my mass number. Mass number. Right, mass number. Right, this Z here is what is my atomic number. Atomic what number, or proton number. Right, here is what is my ion. It's okay. Now you can see that from here we don't have electron number. You cannot know electron number here, but there's a formula that relates what electron number. Now proton number is always equals to what? Is always equals to what? No. Ion is always equals to what? Proton number minus what? Electron number. Right there. So now if you should what? Make electron number the subject of formula here. Because for you to get this is my mass number. Here what is my atomic number. Atomic number is just the thing as proton number, right? Now ion is what? Proton number minus what electron number. You have make electron number the subject of formula here. Before that, you have to see something like this. You have to get something like this. You have to get what? Electron number is equal to what? Now let's carry this one here so that this one will not be lost. Carry this one outside again. So it's going to be proton number. Now remember each ion moves to the outside, going to be minus what? Ion. So this afterwards get what my electron number, right? So if you look at the question here, right? My mass number is going to be what? 27, because here is what my mass number. This guy corresponds to this guy here. This one is what is my mass number. Here's what is what atomic number. Here's what is what my ion, right? So share it very well. My mass number is what is 27, right? Now let's get our electron number. How do we get our electron number? Electron number is equal to what? My proton number. What's my proton number here? 13. Is what is 13 minus. Where's my ion? My ion is what is plus 3. Right? So going to be a plus 3. It's okay. So going to be 13 minus 3, which is going to be 10. It's okay. So yeah, my electron number here is going to be 10. So what will that be the answer? So going to be what? 27 and 10. This is the answer here. It's okay. So we have done what with first part of this video here, right? We have done what with first part. Let's go to the calculation aspect. So please make sure you follow the calculation what aspects. So now let's look at what question 13 and question 14, right? So we have entered what the chemistry, we have entered what the calculation of what aspects. So we have this one here. This type of question you are going to see in the calculation aspect. So please pay attention. A gaseous metallic chloride (MCl) consists of what? 20.2% of M by mass. The formula of chloride is. So please pay attention. Let me explain. Let me show you how to do this here. Now, the percentage of mass is 20.2%, right? These are a gaseous metallic chloride, right? So that is the metallic chloride consists of only the metallic chloride that is contain only what? 2 elements: the metal itself and chlorine, right? And the metal they gave us to be 20.2%, right? So what would be the percentage of chlorine? The percentage of chlorine. Now the percentage of chlorine, because since we have 2 elements here and they are percent by mass, if you add 2 of them together, it's going to be 100%, right? So the total of them is going to be 100%. So if this guy is 20.2%, what will be the percentage of what? Percent by mass of what? Chlorine. Subtract this from 100. So it's going to be what? 100 minus 20.2. Here we have 79.8. 79.8 what percent. Just that. Now after I've got you what your percentage of the metal and percentage of chlorine, this is what we do here. So you draw a table, elements, the elements, the metal M and the chlorine, right? What is the percentage? So you can say of percentage 20.2 and here we have 79.8. Now once you have done it here, right? The next thing you want to calculate is the mole. So how do you calculate the mole? This one, remember when it comes to chemistry calculation here, Mole goes to mass, or what? Atomic mass or molar mass, right? That is what mole. Mole goes to mass over what? Atomic mass of the element. That is mass of the element, but what the atomic mass of the element, right? Yeah, they give us percentage by mass, so they also use it as well as the mass, right? Yeah, they give us the atomic mass of the metal to be 27. The atomic mass of chlorine is 85.5, right? So you're going to be what? 20.2 over the atomic mass of M is what? Is 20 what? 7. Just that over here we have what? 79.8 over what? 35.5. Just that. So now let's divide it here. 20.2 divided by what? 27. 0.748. So here we have what? 0.748, right? Just when you divide it, then this 79.8 divided by 35.5. Here we have 2.247 or 2.2479. Just that. So this divided by this to get this here. This divided by this to get this here, right? Now, once you have done this one here, please pay attention. Once you have done this, next you want to do is what mole ratio. So you can say what mole ratio. Mole ratio. How do you calculate mole ratio, right? Now you divide by what? By the simplest mole. Remember the mole ratio will be what? The metal ratio what? The chlorine. Just that metal plus what? Ratio what? The chlorine here. You're going to divide by what? By the simplest mole, right? So the first step, now to solve this kind of question, the first step is to write the elements, then write the percentage, right? Then divide each of the percentage by mass with their atomic mass. Atomic mass of what? Of M is what? Is 27. So 20.2 is over what? 27. Here we have what? 0.748, right? Same thing here, 79.8 divided by what? The atomic mass is what? 2.2479, right? After I've done that here, you want to look for the ratio, the mole ratio. How do you get the what? Ratio? If I divide by the lowest. The lowest here we have 0.748. Here we have 2.2479, right? Divide by the lowest. Here the lowest is what? 0.748. So it's going to be 0.748 over 0.748 ratio. Here we have 2.2479 over 0.748. This is that. So it's going to be what? M ratio chlorine is what? 1 ratio, right? So you have 2.2479 divided by 0.748. So you have what? 3. It's okay. So that is my formula here. So they're asking what is formula here. My formula is going to be what? Now M is what? 1. So you can see that formula of compounds is equal to what? M1, right? Because M is going to be what? 1. Then Cl what? 3. It's okay. But we can ignore the 1. So you now have what? MCl what? 3. So what is the answer here? C. C is what? Is the option. So now whenever you see this kind of question like this, now they may give you all the percentages or they may only give you 2 or 1. Do you understand? Now if it's 2 elements, they can give you 2 or they can give you 1, just like this here. So what question like this in the exam is, it should be a bonus mark for you. Now carry the percentage and divide by what? The atomic mass of what? Of the elements. You'll be given what? The atomic mass. Once you have gotten what? This mole here, divide by what? By the simplest mole, right? You want to arrive at this answer here. Once you get here, you plug it here. Do you understand? Now I've done a complete video on empirical molecular formula. In case you want to watch that video, I will leave the link at the description below. Or say you want to get the complete video on empirical molecular formula so you can understand it better. So now let's look at what the second question. Look at what the second question here. Look at what the second question. So if you look at what the second question is, that what is percentage by mass of oxygen in what? Aluminum sulfate dihydrate, right? Here we have 2 molecules of water. Now the first thing we want to do here is to calculate the molar mass of the entire compound. Do you understand? Because percentage by mass percentage by mass of elements is equal to what? N times atomic mass of the elements over what? The molar mass of the compound times 100 over what? 1 times what? 100 over what? 1. So this is the formula you are going to use here. Is okay. Percentage by mass of elements in the compound times N. So we have to say what is N? Times the atomic mass of the element over the molar mass of the compound times 100 over 1. This is the simple formula you want to make use of. Do you understand? Now, what is N? N is equals to what? Numbers of what? Of moles. Numbers of atom. It's okay. Numbers of atom, right? Atomic mass is atomic mass of the element. Molar mass is the molar mass of the compound times 100 over what? 1. Now, the first one to do here is we'll calculate what molar mass of the compounds. So, how do you calculate the molar mass of the compound? Yeah, look at the molar mass of the compound. Molar mass of what? Al2SO3, right? SO4 3. Here we have what? Dot 2H2O. So let's calculate it. Let's calculate the molar mass here. Let's calculate what the molar mass, right? So it's going to be what? 20 what? Aluminium is what? 27. You can see that the atomic mass is given to us, right? So it's going to be 27 times what? 2, right? Plus. Now, if you change place here, this 3 is affecting every single thing here. So it's going to be 3. It's okay. Now, do you know the reason why they square bracket here? Because this 3 is affecting the all of this one here. Now, sulfur, what is sulfur? Sulfur is what? Is 32. So it's going to be 32 times 1 plus. Oxygen is what? Is 16. So it's going to be 16 times 4, right? Plus. It's okay. Now, yeah, this 2 is affecting water. So it's going to be 2. Right? So it's going to be what? 1 times 2 plus what? 16 times 1. Do you see that? So let me explain it again. You have to get what the molar mass of the compound. Do you understand? How do you calculate the molar mass of the compound? The molar mass of the compound, yeah. The atomic mass of aluminium is given to me to be 27, right? How many atoms of aluminium do you have here? So here we have 27 times 2 is what? 54. So here we have what? 54 plus. Yeah, 32 plus 64, because 62 times 4, 16 times 4, 64 plus 30 plus 32 times 3. So 32 plus 64 times 3. So when you evaluate the whole option here, this plus this times this, here we have what? 288 plus. Yeah, you are done with one. Yeah. 1 times 2 plus 60 times 1 is what? Is here going to be 18. 18 times 2, 18 times 2 is what? 36. 6. So if you add everything together, yeah, what do you have? Here we have 54 plus 20, 288 plus 36. Here we have 378 gram per watt per mole, right? So yeah, we are calculating the molar mass of the compound here, right? So I can just write this out. I just say molar mass So you can say molar mass of the compound so molar mass of Al2SO4 3 2H2O is equals to what? Is equals to 378 gram per watt per mole, right? Now let's look at what numbers of atoms. Remember they ask here what is the percentage of by mass of oxygen, right? So let's look at what the numbers of atoms of oxygen in the compound here. So how do we get it here? Remember, we have oxygen here and we have oxygen here, right? How many atoms of oxygen do I have here? Inside the brackets, I have 4. Outside the bracket, I have 3, right? So 4 times 3 is 12. So there is this one I have 12. So 12 plus, right? Here is what 1. These 2 is affecting it. So 2 times 1 is what is 2. You add it together, right? Because you have been asked to what calculate the number of atoms of oxygen. Now the percent by mass of oxygen in the compound here. So since we have calculated our molar mass of the compound, right? Now let's look at what the number of atoms, which is the N. Just and so to do that here, oxygen inside the bracket is 4, outside is 3. 4 times 3 is what is 12. Then you also have oxygen here. Here is 1, right? 1 times 2 is 2. So we're going to be what? 14. So you know that my N is equal to what? 14, right? Now, my atomic mass of oxygen is what? My atomic mass of oxygen is 16, right? So atomic mass of oxygen equals to what? 16. That is it. So let's look at what let's impute everything to the formula now. So you can see that percentage by mass of what? Of oxygen is equals to, right? Where's my N? My N now is what? Is what? 14. So here we have what? 14 times. Now, what is my atomic mass? What is my atomic mass? My atomic mass of oxygen is 16, right? 16, right? Over the molar mass of the compound is what? 3718, right? 378 times what? 100 over what? 1. This that. So it will be what? 16. 6 times what? 14 times what? 100 divided by 348. 59.25. 59.25. So this is the answer here. 59. So percentage by mass of oxygen equals to what? 59.25. 59.25%. Just that. So that is it here. Just and so you should expect this kind of question in your what exam, right? So we have done question 13 and what question what 14. Hope you are following this class here. Let me know what next of question. So let me know what question 15 and question what 16 here, right? So I said, how many molecules are there in 5.6 tm cube of ammonia at STP? You have add what value here. Please pay full attention here. Now this other what mole concepts, right? This is other what mole concept, and there are various formula in mole concept. I'll just briefly explain those formula to you. Now the first formula here you have mole equals to what? Mass over what? Molar mass. So this first formula you need to know here. Mass over what? Molar mass, right? So when the mass of the element of the compound is being given to you, the atomic mass or the molar mass of the compound can be calculated. You can use to get what? Numbers of mole, right? On that formula you can use, you go to what? Numbers of atoms over slash what? Molecule or what molecule over what? 6.02 exponential what? 23. Is okay. So that formula I can make use of is mass of molar mass equals to the mass of atom over 6.02 exponential 23. Next one I want to look at what? Volume of what? Substance over what? 22.4 dm cube. So these are what formulas you can what make use of here. So you have to what take this down. That what the formula here. Now let's look at what the question again is that how many molecules are there? So they give us what? They ask us to calculate number of what? Of molecule. Which is what? Which are looking for. If you check there, they give us volume of ammonia. Volume of what? NH3 is what? 5.6 dm cube, right? Volume at STP, yeah, they say at what? At STP, right? So that which one are we going to use here? Before that, we are going to use do what they say you should look for. If you check there, do what they say you should look for, right? Right? Numbers of what? Molecule or atom. But NH3 is what? Is not atom, is what? Is a molecule. So that's why I say numbers of what? Molecule. They have to look for this guy here, and they give us what? Volume of what? Of ammonium, right? That's what they ask us what? The amount of molecule of ammonium, and they give us what? Volume of ammonium. So we are using what this key formula here. So it's going to be numbers of molecule over what? 6.02 exponential what? 23, right? Equals to what? Volume of what? NH3 over what? 2.4 dm cube. So what do you want to do here? Now, because we are looking at numbers of molecule here, we want to make this guy the subject of formula here. It's okay. Let's make this guy the subject of formula. So if you should make this guy the subject of formula here, what are you going to get? You should get numbers of what? Of molecule is equals to what? This times this 6.02 exponential what? 23 times volume of what? Volume of what? NH3 over what? 2.4 dm cube. It's okay. So now so what I want to do here, so impute this guy here. That's what you want to do here. So you have what? So you have what? Numbers of molecule is equal to what? Now 6.02 exponential what? 23 times. Here we have what? Here we have 5.6 exponential what? 5.6, right? Over what? 2.4. This is that. So what I want to do here, you are going to multiply this and this. I want to multiply two of them. Remember, you are not using your calculator in your exam, right? There's no calculator in the exam, right? So what I want to do here is this times this, right? So 5.02 times 5.6, 6.02 times 5.6. What are you going to get? Here we have, you're going to be what? 3.712 exponential what? 23, right? Over what? 2.4, right? So this divided by this, right? Divided by what? 2.4. We have 1.5. So numbers of molecule, numbers of what? Of molecule is going to be what? 1.505 exponential what? 23. This is not what the answer. It's okay. So now you should learn how to solve questions without using what? The scientific what? Notation here. Here we have exponents here, right? So here we have this times this. You get this here, put this one here, right? This divided by this, you get this one here. So the answer is what? 1.05 exponential what? 20 what? 3. You can see how easy it is. This is that we still have a lot of questions to what? solve. Let's move on.